we are going to start the next lecture of chapter 1 number systems of class 9th mathematics. In this lecture we are going to discuss about some basic properties of real numbers. So first of all, we start this chapter with the definition of real number. So a number whose square is non-negative is called a real number. So what we are saying, if suppose I am talking about the number square root 2, I am talking about 4, I am talking about the number 17 by 3. So what we are saying, if we square all these numbers, if I square this number, if I square this number, if I square this number, then all these numbers, these will be positive. That is positive, or positive means all these numbers will be positive, and over here we are saying it is non-negative. Non-negative means it is 0 or positive. So we are saying all those numbers whose square is non-negative is called a real number. And there is another kind of definition, you can say that all rational and irrational together they are called the real numbers. So all rational numbers and all real numbers, they are the irrational number, they are the real numbers. So if we are talking about the integers, we are talking about natural number, we are talking about whole numbers, whatever we have studied till now, all those numbers, those are the real numbers. So what are the other kind of number? They are called the complex number. That is not the part of your syllabus. So we are restricting over here just for the collection of real numbers. Now the next property we have over here, it is the completeness property. So what completeness property says is that on the number line each point corresponds to a unique real number. We have started drawing the number line like this, that first of all we have drawn the integers. We are saying this is the number line, this is the point 0, this is the point 1, this is 2, minus 1, minus 2. If I have to plot 1 by 2, I am saying this plot is 1 by, this point is 1 by 2. We are saying on this line you take any point over here, that will be a real number. So any point on the number line, that will be a real number. And this is the completeness property, that on the number line each point corresponds to a unique real number, and every real number can be represented as a unique point on the real number line. Next is the density property. Density property means that if you consider any two real numbers, you can find another real number between those two real numbers. As we have seen earlier, that if two rationals are given, we can find infinitely many rationals and irrationals in between those two numbers. Similarly, for irrational, we can find infinitely many rationals and irrational between those two numbers. So that is basically the density property of the real number, that they are dense. Dense means we are saying there is no spacing in between those any two numbers. You can always find another real number between given two real numbers. Next, if we talk about the addition properties of real numbers, then the first property we have, it is the closure property. Closure property means if two real numbers are given, a and b are given, and if we add these two real numbers, a and b, they are real. Real numbers are generally represented with r. So we are saying if a and b are real numbers, then a plus b is also a real number. Earlier we have seen if a and b are rational, then a plus b is rational. But if a and b are irrational, then it need not be irrational. But for real numbers, a plus b is always a real number. Next is the associative property. Associative property means if we add a plus b first, then we add c to it. And suppose I am taking the example 2 plus square root of 3 plus square root of 7, that will be equal to 2 plus square root of 3 plus square root of 7. In this case, first we solve this bracket. In this case, we solve this bracket. So both these numbers, they are same. This is called the associative law. Next is the commutative law, that is a plus b, that is equal to b plus a. Next is the existence of the additive identity. Additive identity means when we add, we want to find some real number. When we add it to some real number, we get the same number. What we mean to say is, you suppose a is any real number, what I can add to this number so that the answer is again a, and we all know that we can add 0 to it. So 0 is the additive identity. Similarly, we are saying 0 plus a. This is coming from this property that addition is commutative. Next is the existence of additive inverse. Additive inverse means we are saying a number a is given to us. What we add to this number so that the answer we get, it is the additive identity. This 0 is the additive identity. We are saying a is any number. What we add to this number so that the answer is 0. 0 is the additive identity, and we know that what we add to this number is we add minus a to it. So if a is a real number, then minus a is also a real number. So we say that the additive inverse exists for all real numbers. Now the next is multiplication properties of real numbers. So first is the closure property. So closure property we have already seen for the addition. Closure means if we add two real numbers, the answer is a real number. Similarly, if we multiply two real numbers, the answer is a real number. Similarly, associativity means, closure means if we multiply two real numbers, the answer is a real number. A and b are real, then a into b is real. Associative means if we multiply a into b with c, the answer is a b into c. Either you first multiply AB then multiply it with C, or you multiply BC and multiply it with A. Answer in both these cases it is same. Third property we have seen, it is AB is equal to BA. Commutativity also holds for multiplication in real numbers. Next is the existence of multiplicative identity. So existence of multiplicative identity means we are talking about a is given any number, the answer we require, it is a, and what we have to do over here, we have to multiply with some number. So with what number we multiply a so that the answer is a, it is 1. So in this case multiplicative identity is 1. Additive identity was 0. 0 was additive identity. 1 is the multiplicative identity. Additive identity means what I add to a so that the answer is a. So what I add to a is 0. Similarly, the multiplicative inverse. When we are talking about additive inverse, we are saying, what we are saying, a plus dash, that should be equal to 0. Here the 0 is from here. So the answer we are saying it is minus of a. Now for multiplicative inverse, what we are saying, a into dash is equal to 1. Multiplicative identity. So what I have to multiply over here, it is 1 over a. But it is important to note over here that 1 over a should not be equal to 0. It means multiplicative inverse exists for each non-zero real numbers. It is important to note that multiplicative inverse does not exist for all real numbers, but it exists for all non-zero 0 real numbers. Except for 0, every element has an multiplicative inverse. Last property is distributive law of multiplication over addition. So distributive law means we are talking about A into B plus C. If we are doing, then the answer will be A into B plus A into C. So this is called the distributive law of multiplication over addition. Now the next we have is some more results on the real numbers. So first is, if A and B are two positive real numbers, it is important, this term positive is very important over here, that this result only holds for the positive real numbers. Then square root of A into B is equal to square root of A into square root of B, and square root of A over B, that is equal to square root of A over square root of B. The most important condition is that both A and B should be positive. Now next we see how we add, subtract, multiply and divide the real numbers. So the first question we have over here is, we have to add these two numbers. So what we are going to do is, it is 3 root 2 plus 7 root 3, and the second number is square root of 2 minus 5 square root of 3. So how we are going to add these numbers is, we look at these values over here. These are the same values over here. So what we are going to do, we are going to write it like 3 root 2 plus square root 2 plus 7 root 3 minus 5 square root of 3. This square root of 2, we are talking over here, this number, square root of 2, square root of 2, you just consider it like some constant A. Suppose I am writing it as A, I am writing it as B. So basically what I am doing, 3A plus A, 7B minus 5B. If I am writing A plus B, it is just A plus B. If I am writing root 2 plus root 3, I cannot further solve this. I can't further solve this. But when it is 3 root 2 plus root 2 and 7 root 3 minus root 5, what I can do, I can write root 2 is common. I am left with 3 plus 1. Similarly, it is root 3 is common. I am left with 7 minus 5. So answer I will get, it is 4 root 2 plus 2 root 3. In the next part, in the next question, you have to multiply these two numbers. So it is 5 root 11 into 3 square root of 11. What we are saying over here, if we have to add these, suppose I have to add these two numbers, the answer will be 5 root 11 plus 3 root 11. The answer will be 5 plus 3 square root of 11, because it is same over here. So answer I will get 8 root 11. Now I have to multiply these two, but we are saying it is 5 into 3 into square root of 11 into square root of 11. Square root of 11 into square root of 11 means 11. So the answer we will get, it is 165. Yes, you can try at your own. The answer is 165. This is important to note over here, that square root of 11 into square root of 11 is 11. It is basically square root of 11 square, and square root of 11 square is 11. Now next we have to divide these two numbers. So it is 15 root 15, and we have to divide it with 3 root 5. So what we are doing over here, it is 15. We can write it like 3 into 5. In denominator it is square root of 5. Now we are using the property on this, that it is 15 square root of 3 into square root of 5, because both these numbers, these are positive. So we can write the radical sign on root 3 and root 5, and in the denominator we have 3 root 5. So square root 5 gets cancelled, and what we are left with, is 5 root 3. This is 3 5s are 15. So we are left with 5 root 3 over here. So this is our answer. So this is basically what we are doing is, we are saying when we are adding two real numbers, the answer is a real number. When we are multiplying two real numbers, the answer is a real number. Although these two numbers, these are irrational numbers, but the answer is rational. But as a real number, we are saying both these numbers, these are real, the answer is real. Both these numbers, these are real. When we divide these numbers, the answer is real number. These properties we have seen in our previous slides, that when we add, when we multiply, when we divide the real numbers, the answers are real numbers. Now in the next question, we have to simplify these expressions. So first expression we have is square root 3 plus square root 3 and 2 plus square root 2, and we have to multiply these two terms. So what we are going to do, we are going to multiply 3 with 2, and then we are going to multiply 3 with square root 2. Next it is square root 3 and 2 are multiplied, square root 3 and square root 2 are multiplied. So we are getting 4 terms over here, 3 plus root 2, 3 plus square root 2, square root 3 plus 2, and square root 3 plus square root 2. And the answers we are getting, it is, for this we are getting 3 2s are 6. 3 and square root 2, we are writing 3 and square root 2. So 3 is a rational number, square root 2 is a irrational number, their product is an irrational number. The answer we are writing, it is 3 square root 2. Similarly, we are writing it is 2 square root 3, and last it is square root 3 into square root 2. The answer is square root of 3 into 2, that is equal to square root of 6. So this is our answer. We cannot further simplify it, because over here it is square root 2, it is square root 3, it is square root 6. So all these are different kind of numbers. These cannot be further simplified. Next is, we have to calculate the value of square root 6, 6 plus square root 6. Next, in the second question, we have to calculate the value of 6 plus square root 6 and 6 minus square root 6. So what we are going to use is a minus b into a plus b. The formula is a square minus b square. So it is a over here, it is 6 square, minus b over here, it is square root of 6 square. So what is square root of 6 square? It is 6. So the answer you will get in this case, it is 6 square is 36 and under root 6 is 6. The answer is 30. So it is interesting to note over here that 6 plus root 6 is irrational. 6 minus square root 6 is irrational, but product of these two numbers is 30, which is rational. But if we look from the perspective of real numbers, these are the real numbers, their product is also a real number. Next is, we have to calculate the square of root 3 plus root 2 whole square. So the formula of whole square is a over here. I am talking about this question. The formula we have is a plus b square, that is equal to a square plus b square plus 2ab. So what we get is a square. This first term we are getting over here, it is a square. Second we are getting it is b square, and the next term we are getting it is 2ab. So again over here, when it is square root of 3 square, the answer is 3. Next, square root of 2 square, the answer is 2. When we are talking about square root of 3 square, the answer is 3. When we are saying square root of 2 square, the answer is 2. So when the next is square root of 3 into square root of 2, the answer is square root of 3 into 2, so the answer is square root of 6. So these are the values we are getting. Now in these values we can add 2 and 3, so the final answer we are getting, it is 5 plus 2 root 6. Similarly, you can try the next question at your own, that it is square root 5 minus square root 2 into square root 5 plus square root 2. So it is again of the form a minus b into a plus b, and the formula you know, and you can use this formula to find the answer as 3. Now in the next question we have to simplify the value of square root of 72 over 5 square root 72 plus 3 square root 288 minus 2 square root 648. So what we are going to do over here is we are going to simplify the values first. So if we look at 288, I am talking about this value 288, I can write 288 as 4 into 72. When I am looking at the value of 648, I can write this value as 9 into 72. So all these numbers, 4 is positive, 72 is positive, 9 is positive, 72 is positive. So we can separate the square roots and we write it like square root of 4 into square root of 72, square root of 9 into square root of 72. Now what is square root of 4? Square root of 4 is 2. This is square root of 4 is 2. And what is square root of 9? Square root of 9 is 3. So it is interesting to note over here that what we are left now is, this is root 72, root 72, root 72 and square root 72. So if we take square root 72 common from the denominator, we will get the term like this. What we are doing, we have taken square root 72 common from the denominator and we are getting the terms like this. So both these square root 72 gets cancelled and the answer we are left with is 1 by 5. So these questions, these seems to be very easy, that just you have to simplify these values, but you must practice these questions so that you get used to how to find the square roots, how to take the common, which terms you can collect and which you cannot collect. So you must practice these questions to understand all these calculations. You must practice these questions again and again. Now in this next question, what we have is, we have to simplify this value. So first of all, we know that if we have to simplify this, it is a by b divided by c by d. If it is in this form, it means it is a by b then multiplied by d by c. This value will convert in this form. So this is the first step we have done over here, that it is division is there in this form and multiplication is there in this form. This value is changed from division to multiplication. The numerator becomes, this is the denominator over there and this is the numerator over there. In these values we are saying, this was the numerator, this is the denominator. And how these values are changed? These are changed in this form, that division is changed to multiplication and numerator is changed to denominator. Now what we have the form over here, this is the number a, this is the number a, this is the number square root of a square minus b square, this is the number square root of a square minus b square. So we are saying this number is in the form a plus b into a minus b. A is clear to you? The value of b over here, it is square root of a square minus b square. So the formula we have, it is a square minus b square. So the answer you are getting, it is a square minus square root of a square minus b square whole square. In place of b, I am substituting this value. So it is a square minus b square. It is square root over here. In this term, it is square root over here and square is there. So we get the answer in this form. So the answer is a square minus a square plus b square. So the answer is b square. This is the numerator part. For the denominator part, again same thing is there. You will calculate this value and you will get the answer is a square. So the final answer you will get, it is b square over a